Counting the number of terms, we can classify the polynomial as follows. 8x power 4. Only one term is present. Number of terms. Counting the number of terms. We can classify the polynomial as follows. This we call it 7x square plus 9. 9x power 4 minus 3x plus 2. How many terms are present? Only one term. We call it monomial. 2 terms, binomial. 3 terms, irrespective of the power. Trinomial. More than 3, say polynomial. Trinomial. 8x power 7 plus 9x power 4 plus 3x minus 7. Say polynomial. More than 3, generally call it polynomial. Counting the number of terms, we can classify the polynomial as monomial, binomial, trinomial, polynomial, etc. We know how to solve the linear equation, whatever the linear equation may be. For example, 5x plus 4 equal to 0, solving 5x equal to minus 4x equal to minus 4 by 5. It's easy. We know how to solve. What is the name of this equation? Can you tell me? What's the name of the equation? On x and y, see, power is 1, power is 1. Power is 1, power is 1 mean we say homogeneous. This we call it homogeneous. Linear equation, first power only. On 2 variables. This also we know how to solve. After solving, you solve it and find we get x equal to 1 and y equal to 1. We are able to get solution and only one solution. We say the solution is unique. Only one. Unique solution. Similar ways, tell me whether you can solve this equation or not. This equation is solvable or not. 2 variable, 2 equations given. We are able to solve it and we got the solution. So the solution is unique. This, can you get the solution or not? Yes, whenever, see, there are 2 variables and only one equation is present mean we can write infinite number of solutions. Infinite number of solutions. Or whenever number of equations is less number of equations, more variables, less equations, there are 2 possibilities. Either the equation or equations should have infinite number of solutions or they may have no solution also. In this case, our answer is only infinite number of solutions. Come on, you say infinite, many number of solutions. Tell me one solution. Tell me another solution. Yes, we can tell ourselves. When I put x equal to 0, y is 3 by 2. When I put y equal to 1, when I put y equal to 1, I get x to be 1. Like that, we can tell ourselves lot of solutions. So this single equation, actually, whenever we are able to get the solution means, solution is there mean, we call it consistent. Whenever the solution is there, we call it consistent. Even here, solution we are able to get, we call it consistent. Only in this case, we say inconsistent and no solution. Whenever unable to get the solution, we say inconsistent. More variables, less equations, we can always solve. So, but you won't get unique solution. You will get infinite number of solution or no solution. Solve. X plus 2y equal to 7. 2x plus 4y equal to 14. Try to solve. How many variables? 2 variables. How many equations? You say 2 equations, but I say we have got only single equation, one equation only. See, try to solve, you will understand whether there are 2 equations or one equation. First equation multiply by 2nf, 2. I get 2x plus 4y equal to 14. Second equation as it is. I get 2x plus 4y equal to 14. Subtract. All the terms cancels. We get 0 equal to 0. It is only a true statement. This implies These two equations are alike. We are not given two equations. Clearly, multiplying the first equation by 2, we are getting the third equation. So we are given two variable and only one equation. Take any one equation, x plus 2y equal to 7. But we get only a true statement. As you get a true statement, equations are consistent and will have infinite, more number of solutions. Infinite number of solutions. Tell me some solution. For example, when x is 1, y is 3. When x is 0, y is 7 by 2. When y is 2, x is 3. Like that, lot of solutions we can write ourselves. Same problem, two variables, two equations. It looks as if we can get a unique solution. Try to solve it. First equation multiply by 2. I get 8x minus 6y equal to 14. Second equation as it is. 8x minus 6y equal to 15. Subtract. Left hand side thoroughly cancels. Right hand side I get minus 1. We get a false statement. 0 equal to minus 1 I cannot accept. So we get false implies equations are inconsistent and no solution. We cannot write any solution. Inconsistent and will have no solution. Actually, we are given two equations or one equation in this case. Two. Here two distinct equations. They are inconsistent and will have no solution. True statement means unable to solve, but true statement means consistent and infinite solution. Whenever you get false statement, we cannot solve, we should not solve. So inconsistent and no solution. Next one. 4x minus 3y equal to 1. X plus 2y equal to 3. X minus y equal to 2. Examine the consistency of the equations. Consistency. We have to check consistency. There is one immediate method. Determinant, value, copy all the coefficients. See whether the constants, they should be on the left side or on the right side. 4 minus 3, 1. 1, 2, 3, 1 minus 1, 2. If you get 0, then equations are consistent and will have a unique solution. If you want that solution, mean we have to solve by some other method. You get the value slowly, plus minus plus 8. You will get how much? 22. You get some other number. So answer is, if true, answer in this case is inconsistent. Equations are inconsistent. Suppose practically when you solve 1 and 2, for example, ordinary method. If you don't like this method, mean solving 1, 2. Solving 1, 2, I get x equal to 1, y equal to 1. Substitute the values of x and y in the third equation. The third equation, x minus y equal to 2. 1 minus 1 equal to 2. 0 equal to 2. I cannot accept. Whenever I get a false statement, I will tell immediately inconsistent and no solution. We get a false statement, equations are inconsistent and will have no solution. Inconsistent, no solution. Another way we can solve physically these two equations by ordinary method. Get the values of x and y. X is 1, y is 1. Substituting the values in the third equation. If you get a true statement, consistent and unique solution. False statement mean inconsistent and no solution. Examine the consistency of. In this question, solve 1 and 2. Solving 1 and 2. Solving 1, 2. I get, if you solve, x equal to 1 and y equal to 2. Substitute the values in the third equation. The third equation is 3x plus y equal to 5. 3 plus 2 equal to 5. I get a true statement. So equations are consistent and will have unique solution. Consistent and unique, only one solution. And that solution is x equal to 2, y equal to 2. Shall I write like this or shall I write like this? Which one is correct? The solution I want to write this way or this way. Tell me. Second is wrong. We use second only when both are x values. This is ordered pair. This is x value. This one is y value. We have to write the solution like this only. This is wrong. Both are x values mean we have to write this. Here one is x, other is y. We should use ordered pair. Ordered pair 2, 2. First always represents x value. Second always represents y value. Consistent. Find lambda. Find the value of lambda. X plus y equal to 0. 2x minus y equal to 3. Lambda x plus 2y equal to 3. Get the value of lambda. Solve equations which does not involve lambda. Solving these two, I get x to be 1 and y to be minus 1. Substitute the values of x and y in the third equation. Lambda into 1 lambda minus 2 equal to 3. Therefore, I get lambda to be 5. 2 variables. Now 3 variables. Solve and examine the consistency. Solve and examine the consistency. Solve and examine the consistency. X plus y plus z equal to 6. 2x plus y plus z equal to 7. 4x plus 3y plus z equal to 13. And x minus y plus z equal to 2. 3 variables. To get the solution, I need exactly 3 equations if unique solution is there. But we are given more equations, 4 equations. So solve any 3 equations. Substitute the values of x, y, z in the 4th equation. If you get a true statement, we can call it consistent and unique solution. Come on, solve it. We shall solve first, second, and fourth. First, second, and fourth. I want to cancel y, assume. First and third add. I get 2x plus 2z equal to 8. X plus z equal to 4. First, second, fourth. Now, second and fourth, sorry, not first and third, first and fourth. Second and fourth add. 3x plus 2z equal to 9. This is another 5th equation. We are using 1, 2, 4. We are solving 1, 2, 4. Equations 1, 2, 4. Call it 5th. This one is 6th one. Now 5th equation multiplied by 2. I get 2x plus 2z equal to 8. 6th equation as it is. 3x plus 2z equal to 9. Subtract. This way subtract. Means change the sign. X, z cancels, equal to 1. We got the value of x. Yes. Z is 3, correct. X plus z equal to 4. 1 plus z equal to 4. I get z equal to 2. Now take either 1 or 2 or 4. Say 4. X minus y plus z equal to 2. We know x is 1. Z is, 3 only. Z is 3. Z is 3. Substitute 1 minus, yes, correct, plus 3 equal to 2. Solving y equal to 2. We got the values. X is 1. Tell me this way of writing correct or wrong. 1, 2, 3. This way or this way I have to write. The book also, some question, they by mistake, they may write like this. It is wrong. We use this chain bracket only when all the 3 are x values, y values only. Here, this is x, this one is y, this one is z. We have to use ordered pairs. We have to examine the consistency. Solving 1, 2, 4, we got these values. Take the third equation. See whether the third equation accepts this solution. See whether the third equation agrees. Third equation is 4x plus 3y plus z equal to 13. If it does not agree, inconsistent. 4, 6, 3. Correct. Answer is correct. True only. Answer consistent and unique solution. Answer solution also we got. We get a true statement. Answer is what? Consistent and unique solution.